I'm Scott Leslie, this is Jeremy Bellick, and we're with Spinalcom. So let's get into it. We only got 15 minutes, and I've got about 3 hours worth of material here, so let's go fast. All right? All right, so you've heard a lot about IoT and all these billions of devices, right? And all these new jobs created. So we're going to start out with who's going to pay for all this IoT investment. Does anybody wonder where all the money is coming from to pay for all this? So there's a guy. So we focus in the smart building business. Well, a building is a building, and you have tenants and you have owners and you have operators. At the end of the day, they pay a certain amount of money to occupy and use that building. So economics 101, where does economic growth come from? From increased productivity. And we see over the history the type of things that have happened that have increased productivity of humans and therefore caused people to spend more money to buy the technology to put in to whatever they're doing to make themselves more productive. So economics 1001 is IoT. Again, growth comes from increased productivity. Because if we're going to put in all these devices and all this software into a building, where's the money going to come from to pay for it versus the dumb building that people have today? From increased productivity. So we're going to have to demonstrate that value. So what do we need to do? What's different about a smart building than a dumb building? So created a little thing here about Maslow's hierarchy. Everybody Maslow here? Come on, say yes. Pretend you dad. So in a smart build or in a building situation, this is where we operate mostly. But now, can a building make us be more productive, attract more talent, motivate our workers, and drive more brain energy from our people? Well, it better, because we need more and more services in order for people to pay for all this technology and all these jobs. And I think it's absolutely doable. So, Jeremy, thank you. So, the value chain in a commercial property. All the money is coming from the tenants, isn't it? Who else is going to pay for it all? So we need to address these needs, but we need to address more needs. Because all of us as product providers, do we have product providers out there? Service providers? Building operators? The money comes this way. Okay? So we need to look at how do we add value to commercial property today via IoT. Jeremy? So let's look at a couple of use cases here. Okay, how about better maintained building? Higher value to tenants, lower costs to our operators, right? Look at the difference of what we can do in a dumb building versus a smart building. How many people find when they occupy their building, if something breaks, they make a phone call. And they wait and wait and wait. You make another phone call and you wait, and eventually things will be fixed. The building operator doesn't want to fix it because it's expensive. And the building tenant isn't satisfied because the building operator doesn't want to fix it. But in a smart building, we have sensors. We have sensors to tell us how the building is operating, when equipment needs to be maintained so it can be repaired and even prevented. Response is faster, right? What about cleaning? It's scheduled. How many people have been to a building in an office that needs to be cleaned badly because it wasn't on the right schedule? Well, with a sensor, visual and smell sensors, we could have that room cleaned when it's needed to be cleaned. Therefore, we have a better maintained building. Let's go to the next use case. Okay, what about the HVAC system? Okay, in today's dumb building, we have a general thermostat and we have controls. Do humans know how to work a thermostat? I don't think so. If it's cold, what do? They turn it all the way to the highest temperature. Then it gets too hot, what do? They turn it all the way down to the lowest temperature. It goes like this. Never really works. Okay? The air conditioning can't keep up with the elements. It maximizes energy usage. How many times have you been to a facility where it's hot, but they leave the doors open? Okay? In a smart building, we have the ability to occupy or optimize for the tenant usage. We can see where the tenants are, right? Are they in this room or are they in this room? Is there a lot of people in the building? Is there not a lot of people in the building? We can adjust it for the type of use. We want it colder for meetings and warmer for regular work. whatever you want to do. Off-hours service. If you had easily provisionable office hour service, people would be happy to come and work on the weekends. But who wants to work on the weekends when it's 95 degrees in the office? Okay? And we have now the ability to actuate more than just air conditioning. Air conditioning's not all that efficient. But if we could have mechanical electrical shades that could close, door and window suggestions for people, suggestions on which spaces to use at different times of day based on the sun and weather and other times of year, we can again optimize the building's HVAC system, which minimizes energy usage and brings a more comfortable environment to the tenants. So let's go up another level on Maslow's. I'm going very fast because I got limited time, sorry. So what about meetings? What is the point of a business meeting when you have 10, 12, 15 people in the room and you're paying for all those people's salaries? To get a very effective result out of that meeting, okay? In a dumb meeting, it's all kind of done in silos. The AV equipment may be ready, usually it's not. How many people wait 10 to 15 minutes for the AV equipment to start working before they can start the building? Okay, we're used to that one. Okay, how many are waiting for us to get everybody on the video conference for another 10 minutes? So we're into the meeting, the hour meeting, 20 or 30 minutes and hasn't even started yet. And yet you've got 12 to 15 people that are supposed to be productive. The sun is too bright and you can't see the video screen. How many of you have about that one? Okay, nothing is opsonized. Next door, there's a really, really loud meeting. We should have known that. Can't hear what we're saying. And we forgot to order lunch for a lunch meeting, and everybody's very mad because they're hungry and they're not going to pay attention. There goes an hour of 12 people not being productive. But what happens in a smart building? Our room locator tells us what the best room at the time for the meeting is. Everything is provisioned. We know what AV systems we need and they're already ready to go. We get the temperature humidity optimized for the number of people based on the number of people in the room, how hot the sun is, what time of day it is, these kinds of things. We get the lighting adjusted properly. So the lighting could automatically adjust. Right now we're going to do video conferencing. We want the light down a bit, right? Or up a bit, I'm sorry, for the video position, we want it down a bit. So we let the lights go up and down based on what's happening in the room at that time. What about pre-meeting pep? Get the AV equipment to go, ready to go, and let's get all of our tele-attendees on video conference already dialed in, so when we walk in, they're already in the room, ready to go. Okay? We're automatically going to cater coffee, drinks, and the lunch. That's going to be ready. So the meeting starts on time, sorry, and it goes according to plan. We get an hour of comfortable, happy people being productive and energetic and motivated about the business. And meetings are the most powerful way for humans to work together. So let's optimize this. Let's stop screwing around with air conditioning and windows and video screens and video conferencing that doesn't work and have an unproductive meeting, okay? And then when we find a meeting that went really well, why don't we save that as a preset so we can replicate that meeting the next time. Does that make sense to everybody? These are high value to your clients, and this is where IoT money will come from. And there's a lot more like this, okay? So I'm going to turn it over to Jeremy. He's going to talk a little bit about the technology. Do you use this one? And what we do at Spinalcom to enable the next generation of smart buildings. Jeremy?
Thank you. Yes, so the idea here, Scott has tell you what should a smart building do. Here, I'm going to tell you how we enable the smart building. As you will see, I'm the French guy here, so excuse my French. First, this is the definition of what we call a dumb building. Why? Of course, in our definition of the building, we have different services operated by the building. But in fact, what is stupid is that these different services don't talk one to each other. Which means that today, in the building, you have dedicated hardware. To deliver these kind of services, you have dedicated system, which means dedicated hardware, dedicated software, dedicated protocol, dedicated devices. And this leads to closed solution where all the services are totally independent. Security is independent from maintenance, independence from energy, and things like this. And at least these buildings are not connected with the rest of the world. This is done building. Why? Because you give two hands to the building, but these two hands are not connecting what with each other, so they just cannot coordinate. And in order to do this, for example, you have one camera for the security system, another camera for the video system. Why can't we use the same camera for both? I mean, why do we have to multiply all the devices inside the building? So at least today, well, first, well,
That one?
no, the one before.
Sorry?
Just before, just to summarize, a smart, well, we had one before, don't care. Yeah. So at least today, dumb building, it's specific system for specific services. Now what is tomorrow's smart building? Yeah. Tomorrow's smart building, a smart building, well, of course in a smart building there are a lot of more things. But what characterizes a smart building is a smart building is connected with the rest of the world, of course, so mean connected with the cloud and also connected to all the different tenants, all the different building, cars and things at the fog layers. And in fact, inside the building also, all the different systems are connected one to each other. So in a new smart building, you have open software, you have standard protocol, you have data normalization, and this leads to open solution where all these interconnected services are dealt with interconnected things. And you can go. So just to summarize, a new smart building, this is one unified nerve center in the smart building. And on these unified nerve centers that connect all the things, you can deploy, you won't deploy system, but you will deploy just new applications, new software in order to provide these new services. So what does it mean now for the use case that Scott gave to you? This is the nerve center of the smart building, and this is all the organ, which means all the application that we can deploy on the smart building.
Okay. So we'll just wrap by saying again, by taking all the types of devices that are out there and available, we can create any type of service from those same devices by using application-specific services, leveraging the hardware and all the devices that are part of our network. Just keep going one more. Okay. Sorry, we're going very fast here. Okay. So today we want to propose this is for everybody, propose very high value services to our clients. Leverage everything that's available to us. Demonstrate those services by creating models of virtual buildings, and we can talk to you more about that in our booth over there. We'll show a virtual building, how we're operating it right now, and deploy that system into a real building. Okay, thank you very much. We get 3 hours and 15 minutes.